In this video, we're going to talk about MST or multiple spanning tree protocol. So specific, we're going to discuss about what is MST and how it works, intra-region and inter-region, configuration and verification. So first I would like to go through a high level overview of MST or multiple spanning tree protocol. So if you're talking about MST, first initiated by the Cisco, that was known as MISTP or multiple instance spanning tree protocol. Later it defined by IEEE as a 802.1s, but currently it is known as 802.1q or a 2005. So we using multiple spanning tree protocol to avoid unnecessary utilization of resources like CPU, memory and so on. And likewise, a single MST, if you're talking about more as per the MST or a multiple spanning tree protocol, a single MST instance can be mapped to the multiple spanning tree protocol or a common spanning tree protocol. So you may running a spanning tree protocol, rapid spanning tree protocol, they are going to map to the particular instance. So using particular instance, you can create a root bridge, you can decrease the cost of particular interface which is going to the root direction and so on. And it is use RSTP for topology calculation. If you're talking about path election or a selection, it is going to work as a same like a common spanning tree protocol. In other word, like STP or RSTP. So we know very well in spanning tree lower is a better. So the lower cost or lower bridge ID going to be the root bridge, lower cost going to become a root port. Same thing going to be applied in MST or multiple spanning tree protocol as well. And it is also compatible with spanning tree and rapid spanning tree plus or spanning tree. So basically the idea of implementing MSTP is avoiding unnecessary utilization of resources. So for example, if you have a such topology, as we can see, we have a switch 1, switch 2 and switch 3, and we have a VLAN 1 and VLAN 2. Now we can create thousands of VLAN on our infrastructure or layer 2 devices, which is switch. But at the end, they're going to select out only 3 root bridges. So suppose we have a switch 1, switch 2 and switch 3, as well as VLAN 1, VLAN 2 or a VLAN A and B. It could be anything or any number of VLAN. But in this topology, this is the core layer, this is the access layer, or it could be the distribution layer as well. It is depend on your topology system or your configuration, I should say. So let's see, we going to create only these kind of topology. So for sometime for VLAN A, it going to become a root bridge. If it going to fail, another going to become a root bridge. Likewise, if you're talking about VLAN B, same thing going to be happen. So in upper diagram, as we can see, for VLAN A, if this router, this switch working as a root bridge, so I'm going to not forward packet out this interface because of the cost is higher than my this link. Or if this switch working as a root bridge for me, I'm going to send data over this interface rather than this one. Likewise, if you're talking about VLAN B, the same thing going to be happen. So suppose if you're running 100 or thousands of VLAN, so every time you're going to calculate their hello packets, then their information and keep live messages and so on. So rather than going to figure out every VLAN, we can map multiple VLAN out single instance. So maybe VLAN 1 to 100, VLAN 101 to 200, likewise 200 to 300. So we can create an instance of MST MST or multiple spanning tree protocol, and then we're going to configure on a such way, in a such way so that we don't need to bother about all VLAN, we just need to bother about a particular instance where we have mapped multiple VLAN. So this is the basic idea, or I should say the typical idea in order to use MSTP or MST, excuse me. So this is the way why we're going to implement MSTP or multiple spanning tree protocol. So we're going to create a region. A region is something like a domain or an area where every switches in a region range, they are agreed to run MSTP with same compatible parameters. The parameter going to be the name of MSTP, version of MSTP, and instance which is mapping to the particular VLAN. So suppose if we have a switch, we assign a configuration name test, configuration version name 0 to something, and we map the instance 1 to 100. So they're going to belong to particular region which is the test, because we have defined the name of that region. Likewise, in your topology you may have a more than one region. So basically the region is what? A logical area where all switches going to follow the same configuration of MST or multiple spanning tree protocol. Rest of information I have mentioned already in these documents. I'm not going to line by line, but I would like to make you clear or make you a clear picture in your mind what is MST is. What MST is, excuse me. Next thing, which is understanding what is intra and inter region. So the inter region is basically your region where you belong to. So the detail of region are same within the region. And suppose, let me use a switch. Suppose we have a couple of switch right there and some other group of switches out here. So maybe the information of this group A and group B, or network A and network B, is different to each other. So maybe my region name is A and another region name is, or another topology region name is B. So for these switches or these devices, it is considered this is switch A, switch B and switch C. For A, B, C, it is intra region. It is my internal region or my same region. So VLAN to STPI are manually defined. We need to map manually how many or which VLANs we going to map to particular instance. And if we not going to map particular VLAN, that is fall category of common instance of spanning tree protocol. So they're going to execute like spanning tree or rapid spanning tree, whatever configuration is. So that's why if you have thousands of VLAN, you supposed to be map them to particular instance number in order to make utilization of MST. If we're talking about inter-region, the information is different than your. So maybe the connection goes to this switch to this one. For these two switches, they are connected with the inter-region rather than intra-region, because you are not part of my network and you have another parameters. Your parameter is little bit different than my parameter or whatever parameter applied inside my network. Because of that, now I'm going to consider you are belong to the inter-region. So for switch 1, switch 2, switch 1 going to understand switch 2 as a inter-region and switch 2 going to understand as a inter-region to switch 1. Likewise, if you're talking more about a region, there may be more than 2, 3 or multiple region, so virtually they going to consider as a single bridge or a switch. So one of them now going to become a root region or a root switch for region. So maybe you have elected one switch as a root in this region, region 1 or region A, another root like switch X for region B, and root for region C, switch let's see, switch 3. But if we see the cloud, or maybe you have a 100 of switches connected to each other, but their configuration or a MST configuration is different to each other. So now they are going to consider as a single virtual switch. So we are only a single switch. We emulating or we consider as these are the single switches. Again, we going to pick out or opt out, or more accurately choose one of reason to work as a root in order to send data correctly inside a network. The configuration is little bit straightforward. You don't need to bother a lot, because just you need to enable configuration mode, define any name along with version number, excuse me, it is I think version number, and you need to map particular VLAN. So you can select the range of VLAN like 1 to 10, 11 to 20, and so on and so forth. Once you configure the MST configuration, now you need to enable globally your switches to run MST mode rather than spanning tree or a rapid spanning tree. So these two things you required in order to configure MST. Define the instance and related information, or I should say the reason, and enable globally your switch in order to run MST. The verification and configuration going to be the little bit different, because now we going to map 10 or 100 of VLAN to particular instance. So suppose if you want to tune the cost of interface in order to select a root bridge, excuse me, root port, you need to select spanning tree MST and then instance number, then after the cost on particular interface. Likewise, spanning tree MST and instance name, suppose if you selected in instance name 1 and you have already mapped 1 to 10 VLAN. So these 10 VLAN going to be affected, and you can change the priority, as well as you can execute command like, as we can see, show spanning tree interface detail, show spanning tree MST and instance number detail. So some of command going for verify or a verification, as well as some command going to be for modification. The next thing which we are going to do, apply this setting on devices. That make more sense to understand how configuration going to take place on Cisco gears. So this is the topology which we are going to play with. We have a switch 1, switch 2 and switch 3. All switches is 2960 and they are connected with these ports. Along with this, I have already defined to map VLAN 1 to 5 for instance number 1, 6 to 10 for 2 and 11 to 15 for 10 VLAN number 3. In your case, you can map thousands of VLAN to particular instance number, and you may have thousands of switches as well, or maybe 100 of switches. But at the end, they're going to create topology which is look like this, as we discussed earlier. So now the configuration going to be on my devices. So my devices is up and working. So all devices is working. You can see the version of my switches. So most of switches is 2960. There you go. Right. The next thing which we're going to apply in this topology, creating VLAN. So VLAN 1, which is the default VLAN, we don't need to create. In rest of VLAN, from VLAN 2 to 15, I'm going to create now out all switches. So paste on it and then press enter. So now we have 15 VLAN. Let's verify as well. Rather than single VLAN or default VLAN, do so VLAN. We would like to see in brief. We have a VLAN 2 to VLAN 15 as we created, and we have also a default VLAN. In order to your per VLAN spanning tree or common spanning tree run, you need to create this interface as a trunk. That's why it's going to span out every switches. So configure terminal interface gig 0/122 out all switch. So interface, this is switch number 1, gig 0122. Interface range, they're supposed to be, command supposed to be interface range gig 0122 out all switch, switch port mode trunk. Excuse me, switch port mode is trunk. So basically this interface going to work as a trunk. Automatically switch 2 going to inherit the trunking encapsulation or making this interface to work as a trunk. So let's verify, are they working as a trunk or not? Do so interface trunk out every device. We can see switch 1 gig 1 and 2, switch 3 gig 1 and 2, which is this one and this one. Finally we have a switch 2, port number 1 and 24. They created this interface as a trunk, but currently we running spanning tree protocol, or a legacy spanning tree protocol I should say. So in a protocol IEEE, which is the spanning tree or per VLAN spanning tree protocol, is running in this topology, and we supposed to have 15 VLAN or 15 instance of spanning tree protocol, because if we're talking about the common spanning tree protocol, it could be rapid or a per VLAN spanning tree protocol. It's going to create 15 instance because we have a 15 VLAN. So spanning tree root, as we can see, the root is for VLAN 1, VLAN 2, 3, 4, 5, all the way 15 on all switches. So every time they're going to figure out their hello time and their delay and so on and so forth. So unnecessarily they are going to utilize resources of your devices, in my case which is switch. So we're going to enable MST on top of this topology in order to make efficient utilization of resources. So these are the VLAN which are going to map to the VLAN, instance number 1, 2 and 3. So what command going to be execute, I have already mentioned right there. You can download this PDF and go through it. So it is not a big deal to configure MST. So let me go through all devices and spanning tree MST configuration. So we are currently working on spanning tree MST configuration. Under MST we can configure rest of things. So on switch 1 you can execute out all switches simultaneously, but what I'm looking for, I'm going to make changes on switch 1 and copy those changes to out all switches. So name is MyLAN, either you can put anything. then after version number is, excuse me, it is I think reversion number, yeah, revision, sorry, revision number is 1, you can put anything. And once we configure revision number, we need to enable instance. So as we know, we can create 0 to 4094 instance. In my case, this is the instance number 1, and I would like to add VLAN 1 to 5. This is the range which we can apply. Similarly, VLAN number 2 range going to be 6 to 10, and finally VLAN number 3 11 to 15. So we make changes on switch 1. It's supposed to be execute on all switches which is belong to the same region. So execute command do so run and begin with MST, so that I can copy the configuration and paste out every switch. Do so run and begin with MST. So run, and then what I can use, begin with MST. There we go. So this is the configuration. Spanning tree MST configuration, and then name of MST, which is user friendly, you can put anything. Revision number along with the instance which mapping to particular VLAN. So VLAN 1 to 5, 6 to 10, and 11 to 15. So let me copy this one and copy and paste out every switch. So now we can verify. Configure terminal out every switch, create, exit, do so spanning tree root. Now we supposed to run, excuse me, I need to execute one more command, spanning tree mode MST. So we created actually spanning tree MST instance, we map VLAN on it. The final piece which we need to execute command on globally is spanning tree mode MST out every switches. So make sure that every device is on configuration mode. Yes, that is spanning tree mode MST. So once we execute this command, now we have only 3 VLAN, or we have 3 instances of MST. Actually we have all the VLAN 1 to 15, but logically you can say this is only 3 VLAN. Now it is time to verify. Do so spanning tree root. We can see MST 1, 2 and 3, and MST 0 which is belong to your system itself. It is reserved to your system. We created MST 1, 2 and 3. We can check it out we can check it out on every switches. But look at this, who is or which port is working as a root port. So for switch 1, gig 0/2 is working as a root port. For switch 2, F0/24 is working as a root port. For switch 3, none of working as a root port. Now we come to know switch 3 is working as a root for all 3 instance or MST instance, I should say. You can make particular instance to create, we can select particular instance to particular switch in order to make them root. Suppose if you are looking for instance number 2, this is going to work as a root bridge. Instance number 3 or a switch 1 going to work as a root for instance number 3. So by default switch 3 is working as a root bridge for 1 to 15 VLAN, but we can change it. So let's say how configuration going to be changed. In order to change the default root bridge election. So switch 1 spanning tree MST and then after instance number. So for instance number 1 I want to be the root primary. On switch 2 spanning tree MST instance number 2 I want to be the root primary. So currently for instance number 1 switch 1 is working as root bridge, and 6 to 10 switch 2 is working as a root bridge. Likewise 11 to 15 I am working as a root bridge. So let me show you. So execute the same command, do so spanning tree root. Now we can see this is switch 1. In order to get root bridge of MST2 I am going to send data using gig 0/1 out this way. Likewise to get instance number 3 or VLAN 11 to 15 I will send data using interface gig 0/1. Likewise if we can also see MST0, which is the default instance or internal usage instance. So for that again this switch is working as a root bridge. Similarly we can verify out other devices who is working as a root bridge for instance number 1, 2 and 3. So we can see for instance number 1 I will get root bridge using this port. For instance number 3 using port number 24. Likewise we can verify this thing out switch number 3 as well, but once you come to know the concept of MST, it is more than enough for CCNP 2.0. In CCIE we need to discuss or we need to know more about MST. So the rest of thing is going to be apply on particular interface. If you want to change the cost, if you want to change the priority or a port priority and other things, rather than selecting particular VLAN we need to select instance of MST. So this is all about in this video. In upcoming section we are going to discuss different than it.